Hi, hello, this is Pedro J. Molina speaking. Today I want to show you Essential. Essential is my tool for model-driven development. I created this tool and this library to allow me to create code generators in a fast way. We will have a quick overview about the Essential capabilities. With this tool, we can define meta models, templates, and model transformation. But the best thing is to see this with a sample. Okay. So let's open some basic sample, and I will show you. Here is a meta model. We are defining a mail message. So we have some properties: the person who originated the mail, a list of persons this message is sent it to, just a subject and a message of string type. You can see from and to are properties with types person in this case and a list of person in this case. Person is defined here with just two properties as a sample. With this basic building block we can create models. In this case this is a very basic one. We can add new properties, we have some basic types, and we have completion and also error checking, okay, to double check that everything is fine. And you can explore also your model with this tree. Okay, now we can instantiate this model, and in this file you can find an example. Here we are instantiating a first message of type mail message, and we need to set up the properties from to the subject and the message. Here we are instantiating Peter as a person with these properties and so on. Let's think, for example, that we need a new property. It's quite easy to add. It may suppose that we need an age. Okay, this is an optional age for a person. And then when we come to the model, need to save this. Okay, now we have a new property. Here is the age. It's an integer, so we can set whatever. We set up this as optional, so it's okay to have other object with no properties. If we want to make something compulsory, just remove. And now if we validate the model, we will set two errors. That two objects of type person don't have a property that is compulsory, as you can see. Okay. Okay, let's keep it this optional for the sample. Okay, now we have a model, we have a meta model. Now the next thing we wanted to do with this is, for example, to show a model to test transformation. This is a template. This is a string template syntax. String template is a very good template engine created by Terrence Ball from University of California, and is one of my favorites. I keep using it for a long time. So basically we have some templates, as you can see, all contained in a group of templates, and basically we accept parameters to this template, and we enclose the output between these two symbols. The full template contains holes with names. The holes are delimited with dollar signs, okay? And basically here we are using a property from the parameters we receive and apply a template. If needed, we can do the same and to iterate into collections, like message 2 is a list of persons, applying the same template. But in this case we will use this separator to separate the elements. As you can see, it's very declarative. String template do a very good job not to adding control sequence inside the template or side effects that can be complicated a lot. So it's very straightforward to understand, so you can recognize the output. This is just test, plain test directly, and the full recipient will receive just one object. The implicit parameter is id, with two properties, the full name and the email. So we are just getting with these two templates, we are just creating a plain text template for that. We can do something similar for HTML, and here you have the HTML version. It's very similar to the other one, but just using HTML tags, and basically we are using or filling the holes in the same way, only changing the name of the template for the person, for the recipient. In this case, we will put a strong and sublink for the email. Okay, so the next thing is to use this to generate the code to files. So for that we will use a control data formation. This is another DSL. It's very simple. We will pick up the model, the field message in the model we already have defined, and get in a variable with a type, is type it, and then apply the templates. Let's apply the test template to this message and put it in this file, output file. Do the same for HTML and put in this other file. So with this we can execute this transformation, and here we have applied the templates, and this folder we have the output file. Let's take a look. Here is the two versions, and here we have, this is the message with the template resolved for us, and also we can show you the HTML version. Maybe we can see this better in a browser. Okay, as expected. Okay, this was the very simple example. We have a meta model, we have a model, instantiation of the meta model, we have some templates using the properties on the model to produce code, and we have a control to control how to apply the transformation. Let's go to do that something more elaborated. Okay, let's go for another sample. Okay, this sample contains a class model for a very basic class model, a meta model for a class model. So we have a model root with a name and a list of classes. We have a class with name, description, optional, and a list of properties. Each property will have name and type and relations. Okay. On the other hand, we have a database schema. This meta model is for a database. We have a schema with a list of tables. Each table has columns, primary keys and foreign keys. Each column has name, description, type, and primary key and foreign key. If we want to make this meta model specific for a database, we can extend the previous meta model and extend the class column to add a new property called SQL type, for example. So in this case, we can reuse meta models to create more specific meta models. Finally, we have another meta model for settings. We can choose what type of output we want to achieve. For example, SQL for SQL Server, or Oracle, or MySQL, yes, as an examples. So with this in mind, we have an input model that is an instantiation of the class model. So we have a model with some classes, a class with a name, customer, and some properties, and so on. This is an internal representation. You can create this model if you want with your favorite UML tool in a graphical notation or textual notation like text UML or whatever, and later on derive this model. Okay, so and also we have some settings. Yes, we wanted to generate for SQL Server, this version of SQL Server, and in these files. Okay, so what we are going to do is, this is the control sequence. We are going to read the settings, read the model, and serialize the model to disk, just to take a look to that. This is the class model. Here we will apply a model to model transformation to transform a class model into a schema model. And this is a model to model transformation, and we store it in this variable. Okay, and serialize this to this again, just to show you for debugging purposes. Finally, we can pick up the schema model and then apply templates to generate SQL scripts. Okay, so let's take a look to these two steps. First, how to convert the class model into a schema. Okay, let me show you. This is a DSL for transforming models into models, changing the meta model. In this case, this is the input, a class model and a database settings, and the output is a schema. So we have some rules how to map one to the other, and we are mapping properties that are direct. Sometimes we need to do iterations and say, okay, we will transform classes into tables. Okay, so we apply the for all keyword to process all the classes and convert them into tables. How to do that? We have a rule to transform a class into a table, and we map the properties and iterate against in the same way on the columns. And finally, the column maps some properties, and based on some tables, based on the dialect, we can set up the specific SQL type we need to convert for different variants of SQL Server, SQL if needed. Okay. So the next one was the template, the Hem project. So here we have the Hem project template. It resides a schema. So we will iterate in all tables and create a table. For each table, we will need the name and iterate on columns with this separator. And for each column, we will say, okay, this is the name, this is the SQL type. If this allows null, we will set up null or not null. And that's it. This is a full example with all this step. Let's execute it and show it. Okay, this is executed in just 71 milliseconds, quite fast. So it's all model interpretation, and we can again take a look to the output. Okay, the first model. Okay, it's just the model with the class model, classes and properties. Okay, the second one is the schema model. In this model we have columns, tables and schema. Okay, already converted into the second model. And in the final one we have the tables. We have the tables with the properties. So as you can see, this allows to create code generators in a fast way, because as you can see, it's a very few line of codes, and meta models, templates and transformation model to model are all kept in different files. It's very easy to debug and to evolve a code generator to produce very complex code if needed. And use this for commercial projects. I have been using this in some of them with success. So if you want to try Essential, and if you want, I would love to have your feedback on that. Feel free to download it, try it, and give your comment about it. Thank you for watching. Bye.